Now, today we are discussing uh, Laplace transformation of cosine and sine function. Yesterday we have discussed hyperbolic functions, and today we are discussing the cosine and sine function. You have to understand the techniques involved in computation of Laplace transformation of this. Now let us consider that. You know what is L of cos Wt, very shortly denoted as LC. LC is equal to integral 0 to infinity e raised to minus st cos f of t. Instead of f of t we write cos omega t dt. So that we can integrate by what is a method of integration of products. Okay, so first function into integral of second minus integral into derivative of first function into integral of second. So you know the integral product of integral. Okay, integral of product. So that is e raised to minus st into cos Wt. So here they have considered cos omega t as the first function and e raised to minus st as the second function. Cos omega t is the first function and e raised to minus st as the second function. So first function into, that means cos omega t into integral of second. What is integral of second? E raised to minus st by minus s from 0 to infinity range minus integral 0 to infinity derivative of first function. What is that? Cos omega t, the derivative of cos omega t is sin omega t. So sin omega t into then and one omega comes there because function of function rule we apply. So sin omega t into omega, that omega is taken outside, and then I think derivative cos is minus sin omega t. So a minus will come outside. And what is integral of e raised to minus s? That is e raised to minus t by minus s. So there are two minus from the operation inside the integral. So that will get cancelled and the actual minus sign remains there. So divided by s. And s is taken outside. Okay. Now you know we can substitute the value infinity here. When we substitute infinity, it will become 0. When we substitute 0, it will become e raised to 0 is 1. Cos 0 is 1, so just minus of 1 by minus s, that is 1 by s. Yeah, it is 1 by s. And the second time you know that is omega by s into, this is actually what is that, a Laplace transformation of sin omega t. So that is written as ls. Similarly, we can directly compute the ls. So what is ls? Integral 0 to infinity e raised to minus st sin omega t dt. First function sin omega t is taken, and therefore sin omega t into e raised to minus st by minus s from 0 to infinity minus integral 0 to infinity derivative sin omega t is cos omega t into omega. So that one omega is taken outside and the cos omega t is written here. Then integral of e raised to minus st, that is e raised to minus st by minus s. So one minus sign will be there inside the integral, and already minus sign is outside integral, so that will get so that will become plus sign. Okay, so omega by s integral 0 to infinity e raised to minus st cos omega t dt. Now let us put the values. If we substitute infinity, sin infinity e raised to minus infinity is actually, what is that? E raised to minus infinity is 0. Okay, so first term is 0. Then substitute 0 sines. So e raised to 0 is 1, but sin 0 is 0. So first term becomes 0. Now let us look at the second term, that is omega by s into, what is it? This is Laplace transformation of cos omega t. So that is written as LC. So the result is omega by s into LC. I think you got the idea of computing this LC and LS. You look at this expression, that is LC is in terms of LS and LS in terms of LC. So we can compute LC or LS simply. So just substitute what is LC. S is equal to 1 by S into omega by S into instead of Ls we write omega by S into Lc, that we so we get Lc into we can take combine together Lc into 1 plus omega square by S square, that equal to 1 by S. So that is Lc equal to S by S square by S square plus omega square, right? So similarly we can Ls is nothing but W omega by S by Lc. So just substitute this Lc here, and we can use these two above equations, and we can simply see that Ls is nothing but omega by S square plus omega square. So what are the formulas? Laplace transformation of cos omega t is S square by S square plus omega square. And Laplace transformation sin omega t is omega by S square plus omega square. So we have four Laplace transformations. One is one is L of cos HAT, then L of sin HAT, then cos omega t, then sin omega t. So four Laplace transform. In the case of a hyperbolic function, S by S square minus A square, but for cos omega t, Laplace transform S square by S square plus A square or plus omega square. Okay. In the case of sine function, for the hyperbolic function, it is A by S square minus A square, but for sin omega t, it is A by S square plus A square. Okay. So this difference. Okay. In this example, L of t raised to n plus 1. I think we have discussed in the last class. Integral 0 to e raised to minus st t raised to n plus 1 dt. We can consider t raised to n plus 1 as first function. So t raised to n plus 1 into e raised to minus st by minus s from 0 to infinity plus integral 0 to infinity. What is the derivative of t raised to n plus 1? N plus 1 into t raised to n. So n plus 1 is taken outside, t raised to n remains there, into e raised to minus st by minus s. So that minus and the minus outside the integral, that will become plus. N plus 2 is taken outside and s is taken outside. So this is Laplace transform of t raised to n. Okay, this is Laplace transform of t raised to n plus 1. So we can see that L of t raised to n plus 1 equal to n plus 1 by s into, this is 0, this term is 0. So L of t raised to n plus 1 is equal to n plus 1 by s into L of t raised to n. So substitute these values. I think we have already discussed the computation of L raised to t raised to n. So this is n plus 1 factorial by s. Now we discussed two fundamental theorems. So we have obtained several, yeah, this is given here, several formulas for, we will compute this one also, and we have to use shifting theorem. So one is S shifting theorem, that means replacing S by S minus A or S plus A. Okay, so this theorem is very fundamental and it is required for further analysis. If f of t has a transformation capital F of S, whereas then e raised to at into f of t has a transformation f of S minus A. Okay, if f of t has a transformation capital F of S, e raised to at f of t has a transformation f of S minus A. Look at this table. Here we have S minus A by S minus A square plus omega square. So you know what is the Laplace transformation cos omega t? That is S by S square plus omega square. Then what will be the transformation of e raised to at into cos omega t? That is S, instead of S we use S minus A by S minus A square plus omega square. That is Q. So that is based on that shifting theorem. And similarly for the case of sin e raised to at into sin omega t. So we will consider the proof of theorem 2. This Laplace transformation of e raised to at into f of t is equal to f of S minus A, that we have to prove. Or in other words, the inverse of f of S minus A is nothing but e raised to at into f of t. So we should have these two results and we can apply this result for the complicated problems. Now let us compute what is f of S minus A. By definition it is integral 0 to infinity e raised to minus, instead of S we use e raised to minus S minus A into t f of t dt. Okay, so we can modify like this, here integral 0 to infinity e raised to minus st e raised to at f of t dt. Okay, so this is, so instead of f of t it is e raised to at into f of t. So we can compare this entire expression with the definition of Laplace transformation. So instead of f of t, here we have e raised to at into f of t. So this is the Laplace transformation of e raised to at into f of t, right? So we can write like this, L of e raised to at into f of t. Now we have to ensure that S minus A greater than k, then only f of S exists. Okay, if it become negative, what happens? If it become negative, what happens? The negative and negative become positive, and that will be the integration from 0 to infinity. The e raised to function is will be result in infinite value. So to ensure the existence of this integral, we should ensure that this should be negative. So to ensure this is negative, we have to keep, what is that, S minus A. What is that? S minus A is some positive number k. Okay, it should be k is some positive number. Okay, it can be what is that, 0.1 or 0.2 or 1 or 2 or less, whatever it is. It should be a positive number. K should be a positive number. So to ensure the existence of the integral, we should ensure S minus A greater than k. Yeah, it is another problem. It's very interesting. We have, by this shifting theorem, L of e raised to at cos omega t is, instead of S we use S. What is the Laplace transform cos omega t? S by S square plus omega square. What is the Laplace transform e raised to at cos omega t? S minus A divided by S minus A square plus omega square. Similarly, for sin omega t, you know that is omega by s square plus omega square. For e raised to 8 into sin omega t, LT is omega by s minus a square plus omega square. It is direct. Now we can use this equation for solving complicated formulas or complicated situations. Now let us take the Laplace transformation like this. L of f is equal to 3s minus 137 divided by square plus 2s plus 401. Okay. So we can modify that equation. What is 3s minus 137? That can be written as 3 into s. So because we have already, we know that 2s plus 2. What is s square plus 2s plus 1? You should know some fundamental formulas like. I will show you that. So what is s minus 1 into s plus 1? This is equal to, or we can write s minus a into s plus b. This is nothing but s square minus a plus b into s plus minus this is going to let us first expand this. Yes, bs, then minus SBs minus AS, then minus AB, right? Okay, that's one formula, and we can what is S minus A and S minus B? Really? Charge UPS So this is the formula, and kettito. This is a formula, s square minus 2s plus. So if it is positive, not 2, this one. If it is positive, you should know this type of equations, otherwise you cannot solve simply. So basic knowledge of quadratic equations should be with you. So this type of equations can be applied here. So that will be, so that is s square plus 2s plus 1. We can take 1 from 401 and leave 400. So that is s plus 1 square plus 400. So we can modify the numerator using based on this expression. So we can have 3 into s plus 1 minus 140. We can apply the linearity property. So 3 can be taken outside. The L inverse into s plus 1 by s plus 1 square plus 20 square minus minus 7 into L inverse 20 by s square s plus 1 square into 20 square, right? See? Okay, so you have to use your brain, not just formulas. You have to use your brain also. Modify according to the need. Okay, now what is the L inverse of this one? This is a S shifting theorem. Okay, we can apply the S shifting theorem here. So that is 3 into e raised to, it is s plus 1. So s minus minus 1. S minus minus 1. S plus 1 is nothing but s minus minus 1. So that is e raised to minus t. 3 is already there. Cos omega t. Omega means 20. Cos omega t. So cos 20t minus 7 into, this is sine. S shifting in sine. So sine omega t, that's sine 20t. Okay, so I think you got the idea of finding this Laplace transformation of complicated functions using the available information. Okay, so up to this we have studied basic formulas and basic computer formulas for the of the Laplace transformation of the some well-known functions, and then now trying to find out the Laplace transformation or inverse transformation of complicated functions. It's a progressive step-by-step method. Okay, we will discuss the existence and uniqueness of the Laplace transformation in the next class after studying this. So you can do the exercise problem here. I think you in the last class you might have worked out this what is that question number 1, 2 and 3. Okay, now you can solve the problems 4, 5, 6 up to 8. Okay, up to 8. So for that, for the equation, for the questions 7 and 8, you should have knowledge of sin a plus b or sin a minus b. So if you have a +2 level mathematics book like trigonometric geometry, you can look at the book of trigonometric geometry of trigonometric +2 classes. You will get the various formulas for finding this type of equations. Okay, so you can apply that equations with this Laplace transformation. So up to 8 you can do the problem. Okay, എവിടെ ചേർന്നല്ലോ കഴിഞ്ഞോ?